Now see here the next chapter, that chapter is actually ray optics and optical instruments. So this chapter is actually related to light. So first one we are going to do here about ray optics. So see here, first concept of this ray optics is, that is reflection of light. So what do you mean by reflection? See here, reflection is actually the phenomenon of the change in the path of light without change in the medium. Suppose you have taken any surface like this, that is, suppose I have taken a glass plate and highly polished, this is one side, thin glass plate, and one side is highly polished. And we take here one ray like this, the light is falling on this surface is in this way, and it is going to this side after reflection. So when light falls on this point, it after striking this surface, it comes back in the same medium, and this phenomenon is known as reflection of light. This is known as incident ray, and this is known as here reflected ray. So there are two rays, incident ray and reflected ray. Now to define angle of incidence and angle of reflection, at the point of incidence a normal is drawn, this is ON. So angle between the normal and incident ray is known as angle of incidence I, and the angle between the normal and reflected ray is known as angle of reflection R. So see here, there are two laws of reflection of light. First one is here, angle of incidence is equal to angle of reflection, whatever is the shape and size of the reflector. It means if you have taken the plane surface, this law is applicable, and if you have taken a spherical surface also, this law is applicable. Second law is here, incident ray, normal at the point of incidence, and reflected ray all lie in the same plane. So this is here the second law of reflection. So there are two laws of reflection of light here. Now see, besides these two laws, now if you want to make the image by using here reflection of light. So first we take the example of the plane mirror, which already you have done in the previous classes like in the 10th standard. Suppose you have taken a plane mirror in this way, and we keep here an object over here, that is AB. AB is an extended object. This line here we draw here, that is taken, that we can take as a principal axis. For getting the image of any object, at least two rays are required for getting the images. So first we take one ray like this from the top of the object, where when it strikes this mirror, angle of incidence is 0, because it strikes the mirror normally and it is reflected back in the same path. And another ray I take in this way, where is the angle of incidence is I and angle of reflection is here over is R. When we produce these two rays over here, we get the image of this object, and the image is obtained somewhere here. This image is known as A dash and B dash. When we look at this image, we find it here, the size of the object is equal to size of the image, distance of the object from the mirror is equal to distance of the image from the mirror, and also this image is virtual, erect, but it is laterally displaced, laterally inverted. So this is about the nature of the image formed by the plane mirror. Plane mirror is not actually in detail in your syllabus. So we are not going to in much detail about the plane mirror. Now we will come back to the spherical mirrors. So now see, what are spherical mirrors? For spherical mirrors, first one is here. We take here a glass sphere like this, a hollow glass sphere is taken, which has got its center here, geometrical center, and it has got also this radius, and now this sphere is cut into two parts. Suppose I have taken one part here like this, and its outer, this bulging side is polished. When the bulging side is polished, reflection takes place from the depressed part of the mirror, and this mirror is known as concave mirror. So, there are two types of mirror, one is concave, another is convex. If you take the another surface or this surface only, but you polished here from the depressed side. So, now the reflection will take place from the bulging side, and this mirror is known as convex mirror. So, there are two types of the spherical mirror here, convex and concave. So, see here, concave mirror has or the convex mirror has got one is the midpoint of the mirror or the center part of the mirror, that is known as pole of the mirror. This is represented by P. Suppose you have taken mirror M1 and here M2, these two parts. This mirror is a part of the sphere, has got its center of the same sphere of which it is a part. So, this radius is known as radius of curvature, and also this spherical surface has got its center, this is known as the center of curvature. And a line joining the center of curvature and the pole, straight line joining these 2 points, is known as principal axis. Similarly, on in here the convex mirror, there will be here the center of curvature, this will be R, and this line will be referred as here the principal axis. So, now see in a spherical mirror, like a concave mirror, just we have done this one. We have done, this is a pole, this is the center of the sphere of which it is a part, and this line is known as radius of curvature, and this opening of the mirror is known as actually here aperture. So, this aperture is known as actually linear aperture, and aperture of the mirror is equal to the diameter of the mirror. And similarly, if you are taking here the convex mirror, it has also got here the aperture, that is equal to the diameter of the mirror. There are other terminology related to this, and these terminologies are like, if you are taking this plane a concave mirror and we take incident rays. Suppose you have taken this is a concave mirror like this. This is the pole of the mirror, this is the center of curvature, this is the principal axis, and if we take this ray principal axis, I am extending now. If I take here this ray is here, this which is parallel to the principal axis, you know after reflection it passes through, if you are taking parallel axis like this, parallel rays, incident rays, after reflection they passes through a point. This point is known as focus of the mirror. The distance between pole and focus is known as focal length, that is written by small f. So, this small f is known as here focal length. Similarly, we can define here the focal length of a convex mirror. So, now if you are taking a convex mirror, in case of convex mirror, reflection is taking place from the bulging side. This line is known as here the principal axis, this is point P, this is suppose C here. Incident ray I am taking at these parallel here, parallel to the principal axis. After reflection these rays are going in this side, and here they appear to be coming from a point. This point is known as here the focus. But see here the rays are actually not meeting after reflection, they are appearing to meet at this point. So, this focus is known as a virtual focus, and the image obtained by convex mirror is known as the virtual images. The distance between this focus and this pole is known as the focal length. So, we have done now here the about the focal length, radius of curvature, and the center of curvature and aperture, all these basic terminology related to spherical mirrors. Now, see a sign convention. So, for measuring the distances here, we use some sign convention, and these sign conventions are used for measuring the different types of distances, even the focal length, the object distance and image distances. Suppose you have taken mirror like this. This mirror is a concave mirror, and this is the line which is passing through the pole, that is the principal axis actually. Similarly, if you have taken here the convex mirror like this, and this is the line passing through this. This point is taken as a origin, and this is over here origin also. It means all distances are measured from the pole of the mirror. This is the first point of the sign convention. I am repeating it again. All distances are measured from the pole of the mirror. The distance, second point, the distances measured in the direction of incident rays are taken as positive. Suppose incident rays are coming like this, incident rays are coming here, all the distances measured in this direction is positive. Similarly, here in this direction is positive, and all the distances measured opposite to the incident rays, or like this side and this side, are taken as negative. So, pole is considered as origin, right to the pole is positive and left to the pole is negative. And third point is here, the distance is measured perpendicular to the principal axis, whether they are here or here, anywhere, but it is perpendicularly upward to the principal axis, they are taken as positive, and if it is the perpendicularly downward to the principal axis, the distances are taken as negative. Similarly, over here, the distances perpendicularly upward to the principal axis is positive and perpendicularly downward taken as negative. So, in this case here, these are the sign convention we use.